During the break time, I look at the content we have so far. If we have enough materials for homework assignment number 3 by the end of this week, I feel we have enough materials. That means we can start our homework assignment number 3 this weekend, a little earlier, not next week. In that way, with 2 assignments in the remaining 3-something weeks too hard. So let's do our 3rd assignment this weekend. So we will have one more week. So for 2 assignments, so we need at least 4 weeks for 2 assignments. All right, so let's modify our plan. So this weekend we will have quiz number 4 and homework assignment number 3. 2 assignments this weekend. All right. Sorry, what next week? Yeah, more than 1 week. Remember, usually I give you 2 weeks, probably a little too long. So 1.5 weeks. About 1.5 weeks. 2 weeks, too long. If 2 weeks, then there is a possibility. If 2 weeks, then home assignment number 4 should be assigned with some overlap with the 3rd assignment. That we can. Just assign a little earlier. So, before the deadline of 3rd homework assignment, you have 4th assignment. In that way, I can give you 2 weeks. All right. Let me start the slideshow. So now, actually this topic, the remaining 2 topics for part B, most of the knowledge we have learned before, but we need to put things together. All right, B.2, method of undetermined coefficients. All right. Here we do the linear algebra version. Nonlinear algebra, algebraic version we did before. So, method of undetermined coefficients. Remember that choice rules, right? Choice rule. That part we did for the algebraic version. Here, linear algebra version. Find a general solution of y prime equals a times y plus g. So last time we did one example. So let's do another example here. But this time, this g vector is a special vector. The special part is here. This e function has some special property. All right. So let's look at the solution for the homogeneous version first. So we need to find the eigenvalues of A matrix. So that's pretty easy. So we get a characteristic equation, and we can find it two eigenvalues. Yeah, these two eigenvalues. All right. There, we need to find eigenvectors. Yeah. So let's use the first eigenvalue. Yeah, or plug in to this matrix. So we solve this homogeneous linear system. Yeah. But the determinant of this matrix is 0. Yeah. So that means the two row vectors are dependent. So we can only just use one of the two vectors, yeah, to find the x of it. By observation, yeah, we want to use the simple values. So 1, 1, very simple. Yeah, x1, x2. Yeah, the first eigenvector. Second eigenvector, we use lambda 2. Yeah, get this simple matrix, a simple linear system. And we just use one of the two vectors. Yeah, same. Yeah. By observation, we get our second eigenvector easily. All right. So now we can write the homogeneous general solution, right? Yeah. So the homogeneous part, general solution. Yeah. C1, C2. Yeah. All right. So the E part, yeah, corresponding to the two eigenvalues. All right. After this step, now we need to find the YP, particular solution. When we solve for this YP solution vector, yeah, similar to our algebraic situation, we need to choose the correct form of YP. Correct form. Yeah. All right. You can see in the G function, there is this e to the negative 2t function in G. Also, in YH, yeah, you have the same e function. Yeah. That, based on our modification rule. Yeah. So here, you can see the situation is the same as our modification rule. Yeah. Although it's a linear system, yeah, but the idea is the same. Yeah. So here we need to apply the modification rule. Yeah. This is a simple. This eigenvalue is a simple root, right? Simple root of the characteristic equation. Simple root. Yeah. Simple root means, yeah, how do we multiply this term by x for simple root, x squared for double root? Yeah. Here it's a simple root. So we need to multiply t, right? We need to multiply t. Okay? So when we write yp, yeah, so our yp form, yeah, so there is this t times, yeah, so here, t times yt. Yeah. All right, here we need to determine u vector, v vector. U vector, v vector. Okay? Yeah. All right. Yeah. Yeah. So yp. Yeah. All right. So here, our for a particular solution, that's the form we feel matching the given structure. So we need to plug in. So matching the given structure. But the u vector, v vector unknown. So we have some freedom to choose appropriate u vector, v vector. So that's the method of undetermined coefficients. So what kind of coefficients? Vector coefficients. Here we treat these two vectors, u vector, v vector, undetermined coefficients. Okay, all right. Yeah. Yeah. Then we plug in, right? Yp prime, yeah. So you just take derivative, yeah. So product rule, yeah. So you know how to do it. Yeah. Then let's combine, yeah, the like terms, right? Yeah, yeah. So here we can combine the like terms, but y prime p, it satisfies the original equation. So we write yp prime in two different formulas. One from the derivative of the yp form. Okay, yeah, yeah. So we take that structure. Yeah. So we hope if we choose the right structure, then we can find appropriate u vector, v vector. If the structure we guess wrong, then you may not be able to find. Yeah. The question is, yeah, here we need to figure out this is a guess step. Guess the structure. Yeah. All right. So two different representations for yp prime vector, and they should be the same. These two right-hand side expressions should be the same. So we equalize these two formulas so that we can find new equations for u vector and the v vector. Okay, all right. So next slide. So let us, set up equations, but we need to compare the like terms, right? Yeah. So for both sides, let's combine the like terms. Yeah. This side also the like terms. All right. That. E to the negative 2t function corresponds to this e to the negative 2t function. So their coefficient part should be the same, right? So then t times e to the negative 2t, same as t times e to the negative 2t. Then this vector should be the same. The coefficient vector, their corresponding coefficient vectors should be the same. Yeah. So then we can write equations. Yeah. The first equation, AU equals negative 2u, right? Yeah. 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 Natural. Second, these two vectors, U is an eigenvector of A for R. Yeah, here, because look at the form. A matrix times U vector equals negative 2 times U. Is U an eigenvector of eigenvalue negative 2? Yeah. By the definition of eigenvalue, eigenvector, right? So from this equation, you can see U is just an eigenvector of A under the eigenvalue negative 2. We found it, right? We found that eigenvector in the previous step. In the homogeneous step, we found one eigenvector, but this U, because the eigenvector we found just one of a one-dimensional space. Yeah. So that eigenvector. So if we put it in a space, it's a linear space. That space is a one-dimensional linear space. Why one-dimensional? Because the eigenvalue is a simple eigenvalue, right? Eigenvalue. The multiplicity of the eigenvalue is 1. That means the eigenspace Yeah, people call it eigenspace. What's the eigenspace? All the eigenvectors for this particular eigenvalue form a linear space. So we call it eigenspace. But that eigenspace is one-dimensional. Yeah. Yeah, one-dimensional. Yeah, because that eigenvalue has multiplicity 1. Yeah. One-dimensional eigenspace. Yeah. Here, try to get you familiar with the terminology a little bit. Yeah. All right. So here, we need to use that eigenspace to understand this U. U is inside eigenspace corresponding to the eigenvalue of -2. It's a 1D eigenspace. Okay. So the 1D eigenspace, so this eigenvector in that eigenspace, yeah, we find one eigenvector in that eigenspace. Because the whole eigenspace has dimension 1. That means all the other eigenvectors must be constant multiple of this eigenvector, right? Yeah, 1 dimension. Just scale it. To get all the other eigenvectors, you scale this representative vector in that eigenspace. Yeah. This is representative eigenvector. Okay? Yeah. All right. So U can be written as 1A here, constant. A is a unknown constant to be determined, right? Undetermined constant. U equals certain constant A times one of the eigenvectors in the eigenspace. Now that one we choose the representative one. Okay? So very simple. This one simple eigenvector, yeah, representative. So we only need to choose appropriate multiple of this eigenvector to determine that U. Because U needs to satisfy other conditions, right? You have another equation to follow. Yeah. So this A should be used for our second equation. Yeah. We need to have some freedom and adjust the value of this little a so that the second equation has a solution. Yeah. Otherwise, our second equation may not have a solution. Okay? All right. Yeah. So let's move to our second equation. AV plus this given vector equals U minus 2V. All right. Then, so let's combine the like terms. Yeah. All right. So we have this equation. All right. Yeah. So let's simplify it. Yeah. Okay. So here you have unknown parameter. Little a is an unknown parameter. Yeah. So you need to find a solution V. Yeah. Here, before we solve it, yeah. So we need to think about. Yeah. We pause a little bit before we try to find the solution. Yeah. All right. Here, let's look at the unknown part of this equation. Yeah. So this equation, unknown values. This V vector is unknown, right? V vector is unknown, all right? A parameter, unknown. Yeah. So this unknown thing. Yeah. All right. Yeah. Think about. Yeah. Too many unknowns in this equation. Too many unknowns. Okay? Yeah. All right. Now the question. In this equation, first, let me ask you this question. Is it possible that no matter what value we take for this A parameter, we always have a solution for V vector? Let's answer this question first. It doesn't matter what value we take for little a. you can use arbitrary. So it's a question. Yeah. So it's not a. It may not be the truth. It may not be the truth. All right. So think about if we take this little a randomly. We select a random number for this a. Do we still have a solution for v in this equation? Yeah. The answer, you may not be able to find a v solution. If a is not selected correctly, yeah, randomly, yeah. So in general, it may not be right. Then this equation may not have solution. Why? Yeah. Look at the determinant of this matrix. Determinant is 0, right? The determinant is 0. If determinant is 0, we know this matrix is not invertible. It's not invertible. Okay? Yeah. This matrix is not invertible. Yeah. If this matrix is invertible, then it's true. You can select arbitrary little a. We just multiply inverse matrix of the coefficient matrix. Inverse. There is the inverse. We multiply the inverse. Then we can find a v. Okay? But this matrix is not invertible. There is no inverse for this matrix. So how do we find a v? There is no inverse, but we need a solution for this equation. Yeah. That's the reason we need to choose the right a value here. Otherwise, in general, you may not have the solution. Yeah. Only for the right a value, you have the solution. Okay? That's the situation. All right? Yeah. So after this understanding, let's write this whole equation explicitly. Yeah. So let's multiply them out. Okay? Yeah? Very simple. Yeah. All right. After that, what property do you have from left-hand side? What's the obvious property from left-hand side? The sum of the two components is 0. Yeah? You add up these two entry values, 0. The sum. Can we, if the sum is 0, can we say the sum of these two right-hand side two numbers also 0? Right? Yeah. Yeah. Because these two vectors are the same. These two vectors are, so the sum of the two numbers at the right-hand side must be 0, so we can determine a, little a value. Little a must be equal to -2. Now, in this way, you can only choose a to be little a to be -2, then you can find a v vector. Otherwise, you cannot find a v vector. Okay? All right. So now our u vector is known. Okay? Yeah, because we find a value. Okay? We multiply with this. So this is the u vector and the v vector. V vector here. Yeah. V. Yeah. So v vector only v1, v2 only need to satisfy this equation. So there is another parameter we can use. Yeah, here. This is the one of the special case. Okay? Yeah. V vector, special case. Yeah. So V. Yeah. Yeah. But the difference of V1, V2 is 4, so we may have more values for V1, V4, right? Yeah, because we only need V2 minus V1 equals 4. Yeah. So we have some freedom in this V vector. Okay? Yeah. All right. Yeah. Now, our YP with the U with the V. Okay. Yeah. Although we have more freedom in the V vector, but we only need one YP, right? Yeah. Particular solution, you only need one particular solution. It's enough. Yeah. All right, so here, we just find a simple V vector. All right, so YP is like that. Okay, all right. Yeah. YH, YP. Yeah. Okay, all right. So put them together, so the general solution. Yeah. Okay, yeah. So that's the first example. Yeah. All right. Yeah. I think in this example, many parts similar to our, the algebraic ODE, nonlinear linear system. Yeah. Case. Yeah. All right. All right. So that's one type of questions. Yeah. All right. B.3. Method of variation of parameters. Yeah. The same question, but we want to use a different method of variation. We used this method before, right? Remember? In the second order linear ODE, we used this method before. But now, it's in the linear system of ODE. So this method can also be used. Yeah. All right. Yeah. Let's look at the same problem. Yeah. But this time, we will use the method of variation. All right. Yeah. Homogeneous. Yeah. So that part, we can use the previous results, right? We do not need to repeat it again, right? Yeah. All right. Yeah. So the YH part. Yeah. But the YH part here, so we want to write it in a different way. Yeah. Because we need to prepare the form of YH a little more friendly for us. A little more friendly for us. Yeah. Yeah. Here, we try to match the way of method of variation that we used before. Yeah. Remember? Yeah. Yeah. If you still, you can remember a little, details of that variation method. Yeah. All right. Yeah. Variation. Yeah. But here I want to just try to remind you a little bit. Method of variation. So here, this word variation. Yeah. You need to use the understanding on this variation part. Yeah. What's that? Yeah. So let me recall our second order ODE case. All right. Now we need to solve a non-homogeneous second order linear ODE. Yeah. How do we use the method of variation method to solve non-homogeneous second order linear ODE? All right. So this method is like this. First, we find a solution of the homogeneous part. Yeah. That homogeneous part uses the constant coefficient. Yeah. Constant coefficient. Yeah. Because this method is used for some special situation. Right. So here, our homogeneous, the coefficient part constant coefficient, right? Yeah. So that's why. Yeah. So we have the similar situation, constant coefficient. All right. Then we need to get the general solution for the homogeneous part, YH. YH, your coefficient is constant coefficient. Okay? Yeah. All right. Then, how to do that variation part? Change the constant coefficient to a variation object. That's a function, right? Function. Yeah. 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 Variation object. It's a function. Function to be determined. That's the variation thing. Yeah. Here, we have the same situation. We have the constant coefficient for the general solution of the homogeneous part. Yeah. All right? Yeah. But we can write a vector, right? Yeah. We can write, the matrix, Yeah. All right. So now, we need to change the constant object to function object, variational object. Yeah. All right. So here, the constant form, here we use the fundamental matrix, capital Y. This whole thing, this whole matrix corresponds to our fundamental matrix, capital Y matrix. Okay? All right. Then this C is a constant vector. All right? Yeah. Little c is a constant vector. Now, we need to make it a variation vector. That is function vector valued function. Yeah. So, function to be determined. Yeah. A vector of functions. A vector of functions. We need to determine that vector of functions. We need to make the change. All right? Yeah. So here. The change is based on this understanding. Okay? So our YP should take the form capital Y matrix, fundamental matrix, times a variation object, U vector, a vector of functions to be determined. We need to determine this U function. Yeah. So that's the method of variation. Yeah. Yeah. So we connect to our old method. Yeah. So the way to use the old method is like this. Now we can take derivative. Yeah. So here we guess the form of the YP and we try to guess the structure right. So we feel if we take this structure, then it is compatible with the given ODE. No contradiction. If you make this kind of guess, no contradiction. So we can get it through. Yeah. All right. So YP from this structure, product rule, right? Yeah, by product rule. Yeah. So vector matrix, you have the product rule, right? Yeah. All right. Then the second one from the original equation, yeah. So YP satisfies the original equation. Okay? Yeah? Yeah. All right. Yeah. Now you equalize these two formulas. Yeah. Then, yeah. So here, yeah. Homogeneous solution. Yeah. Y, yeah. Because Y, fundamental matrix, capital Y, it has special properties. Yeah. We need to use the special properties of the Y matrix. Yeah. So it's not an arbitrary matrix. Yeah. So in this special matrix, each Y column vector, the first column vector, second column vector, satisfy the homogeneous equation. Homogeneous version of the equation, right? So the first one, the second one satisfy this homogeneous equation. Okay? All right. Yeah. All right. So now the property. Yeah. So now we try to rewrite the form. Yeah. Here I just explain. Yeah. When we use a matrix A multiply another matrix. Yeah. The second matrix, there are two column vectors. Yeah. X1 column vector, X2 column vector. That's the same as this way. Yeah. So the result matrix, two column vectors. The first column vector is A times X1. Second column vector is A times X2. Yeah. That's just you know. So here we need to use this symbol form. All right. Then A times Y. A matrix times Y matrix equals, yeah, we write the Y matrix in two column vectors. Then we write it inside. Yeah. All right? Yeah? So AY. Okay. With that understanding, now we want to look at the solution of this equation. All right. Yeah, so let's copy the related formulas here. Yeah, copy related formulas. All right. And yeah, so that's the, you know, what we have so far. All right. All right. Y1 satisfy homogeneous equation. Y2 satisfy homogeneous equation. Yeah. Y1, Y2. Yeah. So, all right. Yeah. Then Y prime, yeah, here. We need to use Y prime, capital Y prime. Okay? Yeah, like that. Yeah. So capital Y prime, right? Yeah, like that. Yeah. All right. So, yeah, so we have that. Yeah. Here you can see, yeah, capital Y prime. Yeah. So you can see we rewrite things because we want to make connection. We want to make connection. Here, at the end, we have this capital Y prime equals A times Y, capital Y. Then, capital Y prime equals A times Y prime. Yeah. Then, first term, both sides cancel out, right? Yeah. So now you can see, after we complete this much work, yeah, we can simplify, yeah, because after that we can simplify the equation. Yeah. So our key equation, this is our key equation. Y prime times, oh yeah, I mean, this is the cancellation part, right? This is the cancellation part. Yeah. All right. So after cancellation, we have a much simpler linear equation. Y, capital Y times U prime equals G. G vector. Okay? Yeah. All right. Then we can find the U from this ODE, right? Linear system of ODEs. Yeah. Because Y is invertible. Y matrix is invertible. Okay? Yeah. If it is invertible, it's a 2 by 2 matrix invertible. Yeah. Yeah. All right. Then we have the formula, right? Yeah. Yeah. So So we can find its inverse. Actually, we have the formula of its inverse. Y inverse, Y matrix inverse, we have the formula. Yeah. Before. Yeah. 2 by 2, we have the formula. All right. So we can apply the formula. Yeah. So we have this U vector integral of this vector. Yeah. All right. Yeah. Now, we can do the calculation. Yeah. Because in this example, we have the capital Y function. This is Y matrix. Y matrix, to calculate Y inverse, we have the formula. Okay? Determinant, we calculate determinant of Y. Then we have that formula. Okay? Yeah. Here, we apply the formula to calculate Y inverse. Yeah. Formula for the inverse is this one. Okay? Yeah. So we can write out the inverse. Yeah. We find the determinant of capital Y, determinant. Inverse, apply that formula, so we get a Y inverse matrix. Yeah. All right. Then multiplication Y inverse times G, so we know this U prime. Yeah. Yeah. All right. So U prime, yeah. So, all right. So calculate the, and so U prime, all right? Yeah. So U prime. Then integral. So U function, we take integral, also easy, right? Yeah. Yeah. With constant vector B. Yeah. Constant vector B. Okay, all right. Yeah. So, all right. So then, we want to write the final solution. Yeah. All right. YP. So this is the YP. Okay. All right. YP. We can write it out like this. Yeah. All right. Then the last step. So YH, YP. Okay. All right. Yeah. A lot of constant here. Yeah. All right. Then add them together. Yeah. So the constant part, although you see, a little complicated. One thing is, in this situation, you can simplify it. Although if you leave it like this, it's okay. If you cannot simplify it, you leave it like that, no problem. But if you can simplify, because look at these two. Look at these two. C1 plus B1 the same, minus 2, C2, So here, we do this kind of simplification. Because C1 arbitrary constant, B1 arbitrary constant, C1 arbitrary constant, B1, can we call the C1 plus C2 C1 constant? Right? Yeah. Because C1 here, also arbitrary constant. So we replace C1 by B1 by the C1, right? Yeah. So no problem. Yeah. All right. So here, so C2, combine, C2, Oh, what's wrong? Right. Yeah, B should be there. Yeah, because why we drop that B? Yeah. Anyway, we just simplify slightly. Yeah. So this part, because there is no obvious simplification, right? Yeah. Let's just leave there. Yeah. All right. Yeah. So, So that's the method of variation. Think about if I give you similar questions in homework assignment number 3. If you can handle calculation like this. So you need to understand the method. So I try to give you similar questions. So we finished the linear algebra part, linear system of ODE. So after this part B, so we complete the linear algebra part. So in our textbook, it's chapter 7. So we complete the whole chapter 7. Okay. Chapter 8, another chapter of linear algebra, But that's about the basic knowledge of linear algebra. Yeah. Chapter 8 is just like a review. Some related formulas we need to use, just like a review. So chapter 8, we do not need to. Yeah. No new materials, all old materials. And actually, in this part, we already covered. The formulas that we need to use for this part, yeah, from chapter 8. Yeah. So we complete chapter 7 plus chapter 8 for this topic, yeah, linear systems of ODE topic. Yeah. All right. So Thursday, we will start introduction of Fourier analysis. Yeah. So I will give you for the homework assignment number 3. So my plan is, first, the main part practice, that's the linear system part. Linear systems of ODE, the main part. Yeah. Then there is a small part we haven't practiced for the Laplace transform. There is one small part left. That's the in our homework assignment number 2, we cannot practice. One is the delta function, right? Remember? So that delta function we haven't practiced. So that delta function and convolution related, we haven't practiced. Yeah. So in this third homework assignment, so we can practice delta function and convolution of Laplace transform, then linear algebra, linear systems of ODE. Yeah. So then Thursday, we will do some Fourier analysis. Yeah. And because our homework assignment number 3, the duration will be 2 weeks, right? Yeah, it's quite some time, 2 weeks. Yeah. So then I may stretch the Thursday's lecture a little bit. Yeah. So that means the next lecture, some materials from next lecture I can also include in the third homework assignment. So then we have a lot of materials. Yeah. Plenty of materials for third homework assignment. Yeah. Yeah. Just 10 questions, not 12 questions. Yeah. 10 questions. Yeah. So that's the plan. Yeah. All right, that's it.